Hi guys, it's Ms. Griffin. We're looking at Unit 9, Skill 1C. So at this point you've already done 2 skills on graphing trig functions, but now we're going to focus on graphing trig functions on a given domain. So if you want to take a second to write down your essential question, go ahead and jot that down. And again, we're focused on a given domain, so not necessarily one cycle. That's what you guys have been doing with Part A and Part B. Now we're going to focus on any domain that they might give us. So our steps are still going to be pretty much the same. We're going to be looking at amplitude, frequency, and period, the midline, the min, and the max, but also doing a starter graph. And our starter graph is going to help us because we are not necessarily plotting one full cycle. We might be plotting more than one cycle, less than one cycle, etc. So we see that this is obviously a cosine graph, and we see that they are asking us to plot it from 0 to 180. But I still want to figure out where exactly I'm plotting my points based on the amplitude, frequency, and period. So I know cosine graphs, positive cosine graphs start high, they end high, their middle is at the minimum, and then the middle of the middles are on the midline, wherever that happens to be. And so I know that this is my typical cosine curve, so you're going to still use your starter graph with those 5 points. And then I want to figure out where each of my points are actually falling. So we're going to look at our amplitude. Amplitude is always in front of the cosine or sine function, which is 3. Our frequency is next to the x, so that's the 1/2. And our period, we're dealing with degrees, so it's going to be 360 divided by our frequency of 1/2. 360 cut in half, 360 divided by a half actually turns into 720. And you might be thinking about this keep, change, flip method. Keep, change, flip. So 360 divided by 1/2 now turns into 360 times 2 over 1. Keep the first thing, change division to multiplication, and flip the bottom fraction, gives you 720. That's how it works. This one's a nice easy one. You could just type in your calculator though if you need to. Okay, so then also we need to know where our midline is, and that's based on the shift of -2. Our maximum, remember, comes in by taking our midline and adding the amplitude, and then our minimum comes from taking the midline or our shift and subtracting the amplitude. So we have -2 plus 3 is 1, and -2 minus 3 is -5. So this midline should be sitting at -2, or our shift line. And then our maximum is at +1, and our minimum is going to be at -5. And then I'm going to figure out what our values are for this actual graph. I know that out here my x value is 720 because I have one full cycle. One full cycle is the length of the period in 720 degrees. And so then our halfway point is going to be 360. And then our middle of the middles, I just cut 0 to 360 in half, and that's 180. And then on the other side, that would be 540. Okay, so it's just finding those middle numbers. And so because our given domain is from 0 to 180, all I'm going to be graphing on our actual graph is this portion here, from 0 degrees to 180 degrees. And so now I'm going to actually put my axes on the graph below and start sketching only on the given domain. So our shift line was at -2. Our maximum is at +1, and I'm going to skip boxes for every one step. And then our minimum is at -5. And I know that I only have to go to 180, so I'll use 3 boxes for 90. Another 3 boxes gets me to 180. And if you are like Mr. Rogers and you like to put your numbers at the bottom instead, then you can absolutely do that. Mr. Rogers does that because he likes to keep it out of the way and not get confused when he's graphing. Although Mr. Rogers wouldn't get confused when he's graphing because he's just fantastic and he clearly knows how to graph. So again, all we're graphing is this yellow portion here. So I see that at 0, I'm starting at the maximum because it's a cosine curve. And at 180, I'm hitting my shift line or the midline. And there's nothing really happening at 90 that I have to plot. And so this is all that I have. Now I know that this graph would keep going, right? I would keep going like this technically and come back up. However, I was only asked to graph between 0 and 180 degrees. And therefore, I don't even want this on my paper. Because if I plot beyond that 180 degrees, I could potentially be losing points because they said this is your domain. That's the only part on which you should plot. Okay, let's take a look at the next example. Go ahead and start your starter graph with a normal, typical negative sine curve. Right, so negative sine normally looks like that. And then we're going to fill out our amplitude, frequency, and period. This is all based on degrees, so we've got -2, 2, and 360 divided by 2, which is 180. So I know that out here this is 180 degrees. The midpoint would be 90. The middle of the middle is 45 and 135. But notice that this domain is asking us to go from -90 to +90. And so I know that I'm definitely going to have this portion of my graph, but I need to have a portion of the graph that goes backwards to -90, way over here somewhere. And so what's going to happen is I'm going to actually draw another negative sine curve to the left of this, so that it ends up meeting up with the one that I just drew the first time. Because remember, this is cyclic, so it just keeps repeating this curvy cycle. Okay, so then I know that, again, back here would be -180 because a full cycle happens within 180 degrees. Halfway would then be -90, and then the middle of the middle here would be -45. So what I'm actually going to graph on my paper is this yellow portion, which is a complete regular sine curve, but it just happened to be the negative sine curve between -90 and +90 degrees. We also need to deal with our midline, max, and min. And so our midline or our shift is from 3. And, I just realized that I told you the amplitude was -2, but remember we take the absolute value. So this should be a +2, but the negative told us that the graph starts downwards, heads downwards, and then turns back up. Sorry about that. So our maximum, we take our midline or our shift and add 2 from our amplitude, which is 5. And then our minimum is our midline or our shift and subtract 2, which is 1. So here our midline is at 3, our maximum will be 5, and our minimum will be 1. So I'm not going to draw the axes on the far left, I'm actually going to draw it sort of in the middle, and then draw my shift line. Whoa. Try to draw it as straight as possible. If you have a straight edge, that would definitely help. So I know that this is my y-axis, this is my shift line where it's at 3, or my midline, and I have to get up to a +5, so I'm going to skip boxes. This will be 4, and this will be 5 right here. And then 2 and 1 will be down 4 boxes total. Okay, now I know that I'm just plotting this yellow portion of my curve, and I've got to get my x values labeled, so from -90 to +90. So I'm going to do every 3 is 45 degrees. Okay, so I know that at 0, I'm at the shift line. At 90, I'm at the shift line. And at -90, I'm at the shift line, or the midline. Okay, so I just plotted these 3 points from my original graph. And then I know that at -45, I'm at my maximum, because I can see it's up high right here. And then at +45, I'm at my minimum, and then I connect, and we're golden. Okay, so again, if you need to, you can plot the entire original negative sine curve, and then repeat it back here, but you don't want to keep those parts on your paper because you could lose credit since they're only asking from -90 to +90. Okay, let's flip it over. So we've got 2 more. These ones are dealing with different domains. This one looks like it's in radians, and so we're still going to start with our starter graph. It does go from a negative to a positive, so I'm actually going to make my starter graph go like this, just like we did the -90 to +90. And now we've got to figure out what this cosine curve looks like. Typically, a cosine curve starts high, ends high, the middle's at the minimum, and then we have our middle of the middles on the midline itself, or the shift line, however you want to say that. But again, I have to go backwards, and so I'm going to repeat this, starting back here, ending here, going down to the minimum, and then connecting. Okay, so I know that my amplitude is 1/2. My frequency is this invisible 1 right here. And so my period, therefore, is 2 pi over 1, which is just 2 pi. So that means that this first graph in blue ends at 2 pi. The length of one cycle is 2 pi. And so then the halfway point is pi. And the middle of the middles is pi over 2. And the middles on this side is 3 pi over 2, because that would be 270 degrees. Okay, so then I have to do the back side of it. So I know that it would end at negative 2 pi. The middle would be pi, and then the middle of the middles closest to the y-axis would be negative pi over 2. And this should be a negative pi first. Okay, so I need to plot from negative pi to pi. So that means from here to here. This is the only portion of the graph that I'm actually going to plot on my actual graph below. And also let's figure out our midline, our max and min. So midline is related to your shift 4. Maximum, it only goes up 1/2, so this would be 4.5, and it only goes down 1/2, so this would be 3.5. So draw your axes on here. Y-axis should go smack dab in the middle, and then your shift line or your midline. Our midline was at 4, and because it only goes up 1/2, I'm not just going to use one box, I'm going to use 4 boxes for every half. So this will be 4.5 up top, and then 4 boxes below will be 3.5. Okay, so that's where our max and our min are going to be. And then we've got to get this out to just pi, so I'm going to use 3 boxes for every 90 degrees, or in this case, it would be pi over 2. You can come up with whatever scale that you want on your x values, but it's just got to be consistent. So if I use 3 boxes for every 90, then I should use another 3 boxes to get to 180. Okay, so we know that at 0, our graph is starting at its maximum. And at pi, it's going down to its minimum. And at pi, or negative pi rather, it's also down at its minimum. And then at negative pi over 2, it should be right at the shift line, and same with positive pi over 2. And then connect it nice and curvy, not a V shape, but curvy for this cosine curve. All right, let's take a look at our next one. Don't be fooled by this pi over 4 inside the sine function. You're going to treat it the same way you would for any other frequency. So we're going to start, I'm going to just do it down here because I'm probably going to run out of space if I do it up top. We're going to start with our typical sine curve. It's a positive sine, so we know that it starts and ends on the midline. The middle is on the midline. The middle of the middles, the first one is up high, and the second one's down low. And our amplitude is 3. Our frequency is pi over 4. And then our period is 2 pi over 4. So this is where our keep change flip's going to come in handy. So we keep the top, we change division to multiplication, and we flip the bottom, so 4 over pi. Pi's cancel, so that means the period happens within a value of 8. And so therefore I'm going to label this as 8 here. Halfway would be 4, half of that would be 2, and then the other side would be 6. But notice that we have to plot this on 0 to 12. So I actually have to extend this graph, keep it going. I'll plot another complete cycle, so it'll look something like this. And I'll plot my actual points. And then we'll figure out where it would end up landing. So we know a complete cycle happens in 8. And so another complete cycle would then happen in 8 plus 8, which is 16. Half of that would put us at 12, and in the middle of that would be 10 and 14. So it's easy just to plot a second full cycle, figure out your numbers, and then we'll look at how far along we actually have to graph based on the given domain. So in this case, it looks like we're plotting 1.5 cycles, not 1.5 full cycles. That doesn't make sense. So 1.5 cycles because we have to go from 0 to 12. And then, of course, you can figure out your midline. There is actually no shift on this. This is technically a plus 0, so midline is 0. That means our maximum is 0 plus 3, which is 3, and the minimum is 0 minus 3, which is negative 3. So our axes can go back to this edge and then draw it straight across. This, of course, is 0. We've got to get up to 3, so I'll skip a box each time, and this is 3 up here, negative 3 down here. And I've got to get out to 12, so let's see if we can do this every 2, 4, 6, 8, 10, 12. That seems good. Okay, so we're starting at 0 on 0. We know that at 8 it's a full cycle, so plotting 4 and 8 on the midline. And then we know at 2 it's at its maximum, at 6 it's at its minimum. So that's the first part. But then remember, we got to keep going till 12, so I'm going to get up to the maximum and then hit the shift line again, which again in this case just happens to be the axis. And then we have that yellow portion plotted right on our actual graph. All right, let us know if you have questions. Otherwise, get working on your practice problems.